Hello everyone, and welcome back to the Fluctus Channel. The Lockheed Martin F-35 Lightning II stands as the most advanced fifth-generation multi-role stealth fighter aircraft on the planet, an engineering marvel designed to dominate modern airspace. Costing well over $100 million per unit, it is packed with cutting-edge electronic warfare suites, stealth coding, and internal weapon bays. However, its most revolutionary feature is not found inside the titanium airframe itself. Instead, it is worn directly on the pilot's head. This is the Generation 3 helmet-mounted display system, a piece of advanced military technology that carries an astonishing price tag of $400,000. This helmet is far more than just a protective shell. It serves as the central command workspace and visual interface for the entire aircraft. Integrated directly with the jet's distributed aperture system, 6 high-resolution infrared cameras are placed strategically around the outer skin of the airplane. These cameras stream real-time, high-definition video, feeds directly onto the helmet's coated visor. As a result, when the pilot looks down, they do not see the cockpit floor or their own knees. Instead, they see completely straight through the metal structure of the jet, granting them an unprecedented, omnidirectional 360-degree view of the battle space below. Combined with advanced targeting technologies and active radar tracking, enemy aircraft, ground threats, and flight telemetry are projected as digital symbology directly into the pilot's field of vision, allowing them to track and lock onto targets regardless of where the nose of the aircraft is pointing. To harness this immense technological power, every single F-35 pilot must undergo an extreme, highly detailed customization ritual just to get the helmet fitted. It is a meticulous, hours-long process where there is zero margin for error. Technicians at the Aircrew Flight Equipment Facility utilize a high-precision 3D laser scanner to map the exact microscopic topography of the pilot's skull. This digital data is sent to a specialized milling machine to create a completely custom-molded styrofoam inner liner that matches the pilot's head perfectly. If the helmet shifts even a fraction of a millimeter during a high G-turn, it could misalign the internal optics and blind the pilot at a critical moment. Next, technicians perform a detailed pupil alignment using an advanced optical tracking device. They measure the exact interpupillary distance to calibrate the dual projector system inside the visor. The digital imagery must line up perfectly with the pilot's pupils to prevent double vision and severe eye fatigue during long combat missions. Once this intense fitting process is complete, the pilot prepares for flight. The uniform preparation involves donning a specialized anti-G suit, which uses inflatable bladders to compress the legs and abdomen, preventing blood from pooling in the lower extremities during 9G maneuvers. They also don a heavy-duty life support vest containing survival gear and emergency oxygen lines, all meticulously checked by life support personnel for potential pressure leaks. Walking out onto the hot tarmac, the pilot approaches the advanced stealth fighter. They climb up the integrated, flush-mounted cockpit ladder, settling into the advanced ejection seat. Ground crews secure the communication lines and high-pressure oxygen hoses to the helmet. The single-piece canopy lowers and seals shut with an airtight hiss. After final system checks, the pilot taxis to the runway, engages the afterburner, and the F-35 roars down the strip before lifting effortlessly into the air. While the F-35 helmet represents the absolute pinnacle of modern aviation engineering, the essential foundation of keeping combat pilots safe begins on the ground within the Aircrew Flight Equipment Department. Here, life support technicians perform highly critical inspections, rigorous testing, and routine maintenance on standard flight helmets and survival gear used across various legacy fleets. The process is demanding and highly detailed. Technicians completely disassemble every helmet piece by piece, inspecting the oxygen masks for microscopic tears in the silicone. They place the oxygen masks onto specialized diagnostic test rigs, pumping simulated air pressure through the valves to verify that the breathing regulators deliver pure oxygen flawlessly at extreme altitudes, where thin air can cause hypoxia and sudden unconsciousness. Night vision goggles receive identical, rigorous scrutiny. Technicians mount them to the helmets and calibrate them using advanced darkroom test sets, ensuring the dual-tube optics are perfectly crisp, completely clear, and entirely free from visual distortion before a nighttime combat mission. The meticulous nature of this work becomes incredibly apparent when pilots suit up for active operations. Technicians assist the aircrew in a highly disciplined, step-by-step process, ensuring every zipper on the flame-resistant flight suit is fully secure, the survival radio beacon is functional, and the anti-G trousers fit tightly around the pilot's legs. The helmet is carefully placed onto the pilot's head, with technicians adjusting the chin straps, aligning the ear cups, and checking the dual visor mechanism to ensure smooth deployment before the aircrew heads out to the flight line. For legacy aircraft like the F-16 Fighting Falcon, the helmet systems utilize different but highly lethal capabilities. The F-16 employs the Joint Helmet Mounted Cueing System, or JHMCS. This system provides the pilot with a specialized monocle over their right eye, projecting critical flight telemetry, airspeed, altitude, and targeting data directly onto their line of sight. By using magnetic transmitter sensors embedded inside the cockpit canopy, the aircraft tracks exactly where the pilot is looking in real time. This helmet-mounted targeting system allows pilots to lock their heat-seeking or radar-guided weapons onto enemy aircraft simply by turning their heads toward them, completely bypassing the need to maneuver the entire nose of the fighter jet toward the target. This revolutionary capability has dramatically altered the nature of modern dogfighting, proving that legacy airframes can still pack an incredibly high-tech punch when paired with advanced pilot interfaces.
The body, so we're going to go ahead and bring the LPF home. I didn't slay it. We'll get the body airborne.
Transitioning from traditional land bases to active maritime operations, we see how these advanced flight systems function in the most demanding and hostile environments on Earth, specifically regarding the short takeoff and vertical landing variant. Designed for the United States Marine Corps and international allies, the F-35B is an engineering marvel capable of operating from austere land bases and amphibious assault ships. Inside the massive, bustling hangar bay of the amphibious assault ship USS Tripoli, aircraft handlers work under tight constraints and high-stress conditions. Precision towing vehicles carefully maneuver the stealth jets around the cramped hangar deck, positioning them onto the massive hydraulic deck elevators that lift the multi-million-dollar aircraft up to the wind-swept flight deck. Once topside, the unique, gravity-defying capabilities of the F-35B are put on full display. Unlike traditional carrier jets that require massive steam or electromagnetic catapults to get airborne, the F-35B can launch using its own immense engine power over remarkably short distances. On Allied vessels like the United Kingdom's flagship aircraft carrier, the HMS Queen Elizabeth, the ship is built with a distinctive ski jump ramp at the bow. This upward curved ramp helps launch the jet into the air by converting forward-rolling momentum into vertical lift, allowing the aircraft to take off safely even when heavily loaded with fuel and guided weapons. However, the true technological marvel of the F-35B lies in its vertical landing capability, which relies on an intricate, synchronized thrust-vectoring propulsion system. As the jet approaches the warship to land after a mission, the pilot transitions the aircraft into hover mode. A massive Rolls-Royce lift fan positioned directly behind the cockpit opens its upper and lower doors, engaging with the main engine drive shaft via a specialized clutch to push columns of cold air straight down. Simultaneously, the main rear engine nozzle rotates dynamically downward by 90 degrees, vectoring thousands of pounds of hot, afterburning thrust directly toward the deck surface. Smaller roll posts located under each wing provide constant lateral stability by venting bypass air. This allows the pilot to bring the multi-ton fighter jet to a complete stop in mid-air, hovering steadily over the pitching ship before gently descending vertically onto the flight deck. Marine pilots practice this incredibly difficult maneuver through rigorous field carrier landing practice at specialized air stations like MCAS Yuma, mastering the precise aerodynamic balances required to land safely without damaging the ship's heat-resistant deck coating. While the B model specializes in vertical operations for smaller decks, the United States Navy relies heavily on the F-35C, the carrier-borne variant designed specifically for large-deck supercarriers. When compared directly to the land-based F-35A and the vertical landing F-35B, the F-35C features significantly larger wings and wingtip control surfaces. This increased surface area provides the extra aerodynamic lift required for stable, low-speed approaches during hazardous nighttime carrier landings. Furthermore, the wings of the F-35C can fold upward mechanically, allowing the large aircraft to fit into the tight parking spaces of a crowded flight deck. The F-35C is also built with heavily reinforced landing gear structures and a heavy-duty tailhook designed to withstand the violent structural stress of slamming onto a carrier deck and catching an arresting wire to stop completely within 200 feet. Managing these high-stakes operations requires flawless coordination across the ship. High above the deck in primary flight control, officers watch over every single F-35C movement, tracking aircraft positions on a specialized digital display board to ensure the landing area remains completely clear and safe. Down on the loud, chaotic flight line, the catapult control station takes charge. Catapult crew members work quickly under intense wind conditions to attach the aircraft's nose gear launch bar directly into the high-powered catapult shuttle mechanism embedded in the flight deck. The pre-flight process is fast, intense, and highly coordinated. Ground handlers clad in colorful jerseys use rapid hand signals to guide the pilot precisely onto the catapult track. The pilot increases engine power to full military thrust, checking all flight control surfaces as the jet strains violently against the mechanical holdback bar. With a final crisp salute from the pilot to the catapult officer, the launch button is pressed. In an instant, the high-pressure catapult fires, violently accelerating the F-35C from 0 to 150 miles per hour in just 2 seconds, launching it off the bow into flight. This incredible combination of advanced life support technology, custom-fitted pilot equipment, and raw mechanical power ensures that modern military aviation remains completely unmatched in its global lethality. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.